Hello and welcome to STAT 441, the online course at Virginia Commonwealth University. This is the second part of the lecture which covers chapter 2 from the textbook. The topic for this lecture is measures of central tendencies. So in the previous lecture, we discussed some graphical methods for describing quantitative data. Let's look at some numerical methods to describe quantitative data. So we can basically divide it into three categories. The first are measures that will help us locate the center of the frequency distribution. The second will be measures of spread, how spread out the data is. And then measures of the relative positioning of observations with respect to the data set. So basically three categories. We will look at the measures of central tendencies, measures of variation, and measures of relative standing. This lecture deals with the central tendencies, and then the next one will be measures of variation. So let's look at the notation that we will use. The variable in our data set will be denoted by the symbol Y or X. The number of measurements will be N, and then each specific measurement will be denoted by Y1, Y2 through Yn. Okay, let's look at what is the difference between when we use or calculate a descriptive measure for a sample data versus when we do it for a population. So when we calculate a descriptive measure from the sample, it's called a statistic, and it uses either regular alphabets or special characters to denote it. Whereas if we calculate the numerical measure for a population, it's called a parameter and is denoted by Greek letters. The parameters are typically unknown. It's the sample data that we have to calculate. For the measures of central tendencies, there are three most commonly used measures: the mean, the median, and the mode. So we'll look at how to calculate each one and how to use each one to describe the distribution. First, the arithmetic mean. It's simply the average of the measurements denoted by Y bar. There's a bar on top of the Y, and it's just the sum of all observations divided by the number of observations. So let's say if we have n observations, then y1 plus y2 through yn, add all them up and divide by n. So the sample mean is denoted by y bar, whereas if we are calculating the mean for the whole population, it is denoted with the Greek letter mu. Here's a quick example. Let's say we have a small data set with 5 measurements. Then the sample mean will be the sum of all observations divided by the number of observations. We add them up and divide by 5. So that gives us 3.2 as the mean of this data set. The next measure is the sample median. Let's say we have a data set with n measurements. Then the first step would be to arrange these measurements in either increasing or decreasing order. So y1 through yn. And the observation which is located in the middle such that half of the area of the frequency histogram lies to the left and half of it lies to the right, then that measurement in the middle is the median. The symbol that we use for sample median is M, just the letter M. And for the population median, we use the Greek letter tau. Okay, here is how we can find the median for a small data set. We will have to locate the middle observation, and the value of that observation is what the median is. So let's say we have a variable y, and to find the middle location, we can use this quick formula. It depends on the total number of observations. If n is odd, then the middle location is n plus 1 divided by 2, and the value of y at that location is the median. If n is even, then we have two numbers in the middle, so we take the average of those two to get the median. So it will be the observation at the location n divided by 2, and then n divided by 2 plus 1. Let's again look at a quick example for calculating the median. Let's say we have a small data set with 6 observations. So these are the observations in increasing order. Now, to find the middle location, because the number of observations is even, so n divided by 2 is 3. So the third observation, and n divided by 2 plus 1, the fourth observation, which is 8. So average of these two observations gives us the median, 6.5. Then the third measure is the sample mode, which is the most frequent observation in the data set, the observation which has the highest frequency. A data set can have more than one mode. It basically tells us which observations are occurring the most. Here is a look at how we can understand these three measures with respect to the relative frequency distribution. So if you look at the first graph here, the mean can be treated as the point of balance for our graph or for our data. The median will be where we have 50% observations below and 50% above it. So it's kind of 50% area above and below the median. And the mode denotes the peak of the distribution. Okay, here is a look at these three measures with respect to the shape of the distribution. So depending on how skewed the distribution is, we will see a relation between these three values. So if you look at the first graph, we have a symmetric distribution. It's a bell-shaped curve. And for a symmetric distribution, the mean, the median, and mode, they have values very close to each other. Whereas if we have a skewed distribution, then what happens is that the mean gets pulled towards these extreme values. So in a skewed left distribution, we have some extremely small values and the mean gets pulled towards it. So this is the mean. Then median is the actual center with 50% on each side, and mode is the highest frequency. So you can see for a skewed left distribution, the mean is smaller than the median, and median is smaller than the mode. For a skewed right distribution, it would be opposite. The mean gets pulled towards the higher values. So mean is the largest, then median is smaller than the mean, and mode will be the smallest. Okay, here are a few notes about when to use the mean and median and mode. First, for the mean, it's a very commonly used measure of central tendency. But while using the mean, be careful and be aware of the shape of the distribution. If there are extremely small or extremely large values, the value of the mean will be shifted towards those values. So basically, it gets shifted towards the tail of the distribution. It could be misleading in certain situations. Here is a quick example. Let's say we have a data set with first year starting salaries of civil engineering graduates. Then if there are a few salaries which are extremely large, that would influence the mean. So in that case, a median would be a preferred measure to understand the center of the distribution. Then median is the more resistant measure of central tendency, and it doesn't get influenced by extreme observations. So if you know if the data is skewed, then a median would be a better representation of the center of the distribution. Last, mode. Mode is preferred over the mean and median only if the interest is understanding the frequency of the distribution. Here is an example to kind of compare the three values and the shape of the distribution. So we have a data set of 2,929 aftershocks in a 3-week period for the Northridge earthquake in 1994. Okay, so we have measurements for magnitudes of these aftershocks, and then we have inter-arrival times recorded by the US Geological Survey. We want to find the mean, the median, and mode for both these variables and then interpret those. And then we have to figure out which one is a better measure for describing the center of these two variables. So for getting the descriptive statistics, we use a computer program. And for all the observations for the first data set, which is the magnitude, the mean is 2.1197 or 2.2. 2.0 is the median and mode is 1.8. For the inter-arrival times, 9.77 is the mean, 6.0 is the median, and 2 is the mode. Now let's look at the shape of these distributions also. So the shape of these distributions look like this. The first histogram is for the magnitude. It is mostly symmetric with a slight skewed to the right distribution. And then the inter-arrival times is obviously heavily skewed to the right. And that's kind of what the numbers were showing us. So let's look at the interpretation of, or the summary of these numbers. So for the magnitude, the mean, the median, and mode are 2.12, 2.0, and 1.8. So what does that mean? That on an average, the magnitude is 2.2. Half of the magnitudes fall below 2.0, and the most commonly occurring magnitude is 1.8. Now, these values are pretty similar to each other, and we also looked at the graph. It was slightly skewed. That's kind of what we see here. The mean is slightly larger than the median, but for most part, it's symmetric. And then any of the three measures would be, we could use to describe the center of this distribution. On the other hand, for the inter-arrival times, as you can see, the three values are 9.7, 6.0, and 2.0. So basically what that means is the aftershocks arrive on an average 9.77 minutes apart. Half of the aftershocks are below 6.0 minutes, and the most commonly occurring inter-arrival time is 2.0 minutes. Now, using the shape of the distribution, we know it's highly skewed to the right, and that's what we are seeing here. The mean is much larger than the median. So if we wanted to describe the center of this distribution, median would be more appropriate because the mean is getting influenced by these extreme values. Okay, this is the link to how to calculate the measures of center using R. Thank you for watching this video. Please watch the next video for understanding the measures of spread for a variable. Thank you.